Hi, I'm Viktor Gamov, developer advocate here at Confluent, and I'm super excited to be here, be virtually, because I didn't go technically anywhere from the place where you probably see me in the last couple months, hopefully. Yeah, and it's great to be here at jconf.dev, and I will be talking about some of the topic that is interested in of mine. I really like to talk about Kafka and stream processing, and also I would like to use a little bit different angle today. Usually I'm talking about how to develop apps, but this time I decided to talk a little bit about how to test those apps. And what are those apps, you might ask? Like, what are we talking about, and what the challenges, what's the problems, and what we're trying to do here. So today I will be talking about testing, and let's do a quick test of our screen. Oh, looks like we don't have a projector in this room, right? Because it's virtual. It's a screen share. All right. So welcome to this talk where will be talking about testing. As a developer advocate, I build highly scalable and highly available Hello World applications. And some of those Hello World applications need to live much longer than just the time where I'm doing this between presentation and so far and so on. So today I will be talking some of the history of why testing is important for me personally, and how I end up in this topic, and what helped me to develop it. Also, I want to say a few words of thanks to my friends that helped me with some of the interesting and challenging questions. We developed some of the interesting content together back in the day. I will put some links in the slides so you will get the idea. But Ivan and Sergey, they help a lot on exploring the topic of testing, right? And probably most important slide, since you're here to learn something, and you want to learn this from the code, not from this just blah blah Victor. You want to learn this from the code, and this is probably a most important slide. So what you want to do is press the pause right now. Press it. Press it. Come on. Press the pause. Okay, and you take a picture, or you can just go to this URL, and after that you find the code. If you don't find what you're looking for, you can always reach out to me in Twitter, which is conveniently placed in the bottom of this slide where you're watching. So hopefully you will get your questions answered from that. Few words about agenda, what to expect in the next 30 minutes. I will give you an introduction of this problem and how this term of Kafka applications, and how are they different, or maybe not different, from other applications that you develop and use. I will talk about how to do local testing using locally installed tools like Confluent platform, which is another installation of Apache Kafka that we developed. There's open source version of it. There's commercial features, but we're not gonna go in the commercial features today. The next thing I will show you how you can improve manual testing by introducing some of the open source framework, namely test containers, that allows you to leverage some of the existing software to develop a integration test for your app. Next thing, we will move to the unit testing, and we're moving to the specific framework to writing stream processing applications, the Kafka streams. And the Kafka streams uses this topology test driver framework that allows you to unit test without any infrastructure. We will talk about this KSQL DB as a stream processing tool, and also what kind of testing capabilities are available there, and how we can mix and match different tools. And at the end, as always, hopefully you will be inspired by always be testing your apps regardless of the complexity. So before we jump into code and we'll start talking about the specifics of the tests, I want to talk a little bit about how I personally came about this and why it is important for me, and hopefully you will find something similar. Because sometimes when I go to conferences, people can say, yeah, you're developer advocate, you're just here for marketing things, but it's not maybe entirely true, because marketing things and like learning this kind of stuff is important, but also I still do code. And some of the things that we develop for people to use, to learn. And many times I've been in situations where I developed some of the examples, or I developed some code, and after that I moved on because I started doing some new presentation or maybe some new talk. And after that, some people can reach out to me and asking like, hey, this example doesn't work with current version, there's something. Or maybe you just found this yourself. How many of you have been in a Stack Overflow when you're looking for something and you get this weird situation that this answer is not working, right? So it reminds me of some anecdote from the past where senior developer is asking junior developer, hey, where did you get this code? And the junior developer was like, yeah, from Stack Overflow. And senior developer, yeah, I understand that, but from the question or from answer? Because sometimes questions also might find some, you might find some interesting things in the question. So we're trying to, once we started developing this new website that I will talk about in a few seconds, we start thinking, okay, so we developed this, and can we spend the time to maintain this? Or we need to provide or like develop the set of tools or techniques that allows us to, develop this code, and it will be always, good. So you will go there and copy this code like year after and still will be working. How we can do this? So the similar problem we were trying to solve while building this website called Kafka tutorials. It's a website where you can take specific use case, and I will talk a little bit about the use case later, and after that implement this using different set of tools. We decided to follow this approach that's called literate programming, and one of the father of this literate programming was Donald Knuth. He expressed this idea of the system where your code and your documentation, they will coexist. So this is one of the things that allows us to develop testable prose, if you want. When you're writing a tutorial or where I write tutorial text, I also writing some code there, and I want to make sure that not only my text would be okay, but also my code will be still executable and still be runnable, and so far and so on. So in this case, we follow this approach, and I would like to introduce you to my little friend called Kafka Tutorials. Kafka Tutorials, it's the kafka-tutorials.confluent.io. This is a website where you can go and learn stream processing, but we're not going to talk about this today so much. This is something that people see when they go to their website. This is something that I see when I'm going to this website, and it's actually dashboard of our continuous integration server that will execute all tutorials. And each use case might have up to 3 different tutorials implemented different technologies. Can be implemented with using just a plain Kafka Producer API. We'll talk about this. Kafka Streams and KSQLDB. And for each of these tutorials, we need to provide a test suite so we can execute this and make sure that tutorial will be constantly successful. So you see the metric. So we're not only growing number of use cases, but also we're growing numbers of implementation details. We also need to make sure that these tests will be executed, and some of the new introduction of new things will not break existing code. So this is what's important for us, and this is how we developed tutorials that also testable, but also teaching you something useful. All right, and what those tutorials are teaching you is the Kafka apps, the applications that allows you to deal with messages that come from the Kafka. So what is stream processing? What those apps doing? Like what's the idea? What we're doing here? And idea behind stream processing is rather simple. It's simple to explain, but maybe not very simple to implement. For example, we have a stream of events that happen, and we don't know when these events will end. For example, website click streams. When you go into a website, they click it around. They want to capture this, to analyze it, to understand how we can improve your experience on this website. So we don't know when you stop doing this, or when you stop and there's some other user will come to website. So we can also analyze this. So it's infinite stream of data, but also we don't want to wait until I don't know, end of the day, for example. We want to get the result as soon as possible. So that's why we're applying this computation as soon as the messages will arrive. And usually this thing in between that, the capture thing is your application, because this is logic, how those messages are combined and how those messages will be, working together and how those messages will be there. If we're talking about, if we're looking into the stack specifically, this stack is also rather simple. Apart from being a very complex and highly available distributed system, in this particular case, it's rather simple. It has three major components. Components that in between that help to capture these events and store those events and process those events and pass these events to the processor. It's called Kafka here. It's in the center. And we have producers, that application that usually write data into Kafka, and the consumer write data into Kafka. So in this particular case, this is a component that you don't develop, and we're not going to focus on testing Kafka today. There's great talks that were done in the Kafka Summit in previous years, where our engineers from Confluent, that company that I'm working for, and we're also providing support, and we're contributing to open source Apache Kafka. We were talking about testing Kafka. So we're not going to be talking about this piece. We're going to be talking about this piece and this guy, so producer and consumer application. And usually producer and consumer application, they might be two separate applications, right? So it can be application that only writing data. So for example, you have some source, you're reading data from some, files, and after that you're producing to Kafka. Or maybe your application have only consumer. You need to read data from Kafka, and after that, doing something with this data. However, in real life, the application frameworks that exist to support that, they are more complex than just producer and consumer. Even your application might also include consumer and producer. And this is the same pattern that Kafka Streams will employ. We'll talk about this. But essentially, we can have a data in multiple different topics, and those topics might include, we can read data from one topic and write data into another topic as a result. An application does this constant processing. This stuff is always on, and you don't need to, run these jobs. It always will be running. Okay? All right. Another thing is that Kafka really don't care what kind of data you're putting there. It's really all about bytes. Kafka reads the data from producer, and on the producer side, we just need to turn this data into byte. So Kafka itself doesn't know anything about your data and cannot introspect it. Same thing with when you need to push the data, Kafka just be there, just an intermediate tool that there and doing something for you. However, we need to make some sense for this data by providing some extra information. Extra information might be just like a Java class that would be available to when the data would be deserialized from the network, or it can be something intermediate, like something that doesn't have notion written in Java, for example, not Java class. So in this case, schema written in protobuf format or Avro format or JSON schema can be used to describe this data, and this thing will be stored inside this small component called schema registry. So this is why also will be required to deal with this in our testing use case. All right, I'm talking too much already, so let's see some code for now. And one of the things that you will see when you get this source code, you will see three projects. And we're going to be talking about all these three projects today. One is the transforming events. So transforming events is just a simple use case where let me talk a little bit about this use case, what we're trying to do here. So our logic is, where is it? Transformation engine. So our logic is simple, as I mentioned in my explanation. So I'm subscribing on the topic with some of the data that just came into our system. While this data will constantly arriving, so in this case we just like have an infinite loop. We're reading these messages for input topic, and after that we do something with this. So essentially this is the logic of our transformation. So what is happening here? We have this convert raw movie. What it does, we're just reading data in one format and turning it into data in another format. This data is explained into Avro schema. So we have this so-called raw movie that includes information about movie year inside the movie title. Maybe there's some legacy system that produced this weird record for us. And we want to produce another version that will include our year as a separate field. So in this particular case, this is what we want to do. So how we can test this? So let me quickly show you. So if I will go here and say, I'm going into transform event, there should be start compose. All these examples are, Dockerized, so I don't want you folks to, go and install particular software. I just want you to focus on the important bits, and the software will be distributed as a Docker container. So we go into event. So in the way how this will work, I do have we go in transforming events, and I'll start the consumer. Consume. And as a result, I want to produce some of data. Produce. And also, I need to do run my application. Okay, so application is not there, so what I need to do is I need to build. Yeah, I remember. Okay, so I'm not only build, I'll need to do shadow jar and test. So in this case, I need to provide a jar that will include all these the messages. So sorry for this. Okay, so in this case, run will be working. Yep, I remember there was something about this. Okay, so now we have this application up and running, consumer and producer. So let's try to produce some of the data. And the way how it works, we see if let's take a look on our internal data. We do have some input data in a JSON format. You see the title includes year, and after that our result is here. So sounds good. So what we will do, we will just capture this output and compare this using diff command in available any Unix system, right? So this would be easy, and that's it. Thank you so much for coming. Thank you very much. No, I'm actually kidding. So it's not exactly like this. So the way how we usually, it's a manual testing. We don't want to do manual testing, and one of the things that you want to do is to automate this process. So since we're already using the containers here, we can apply test containers as a framework for testing our stuff here. So the way how it works, test containers allows me create the same environment that I have in my Docker Compose. I will be using CP Kafka, Zookeeper. There's a Zookeeper container. There's a schema registry container. So for this test, where is it? Where's my startup I creating Kafka container. I creating schema registry container. I don't need to create the Zookeeper container because Kafka container itself will create a particular version of Zookeeper container. Now, in my application code that I'm using, I can use this Bootstrap server, and after that, my Kafka container will be available in my test, and the schema registry also will be available in my test. And the way how my test looks like, so in this case, I'm preparing this fixture data here, and this is my expected data. And based on this, I'm just using this, whatever framework you use, this just simple assert G. That's a simple assertion from JUnit. So I'm using this one, just simple, just works. So In this case, it is just unit test. The hardest part is taken by test containers framework, and how you can get all these things here. It is kind of fascinating. So you can get, if you look into this code, you will get some of the ideas how we can do that. All right. So let's move on to next topic. So let's talk about Kafka streams. So you need to do a lot yourself if you develop stream processing application just using producer consumer API, because there are so many things that already implemented for you by Kafka stream. So you need to think about how you can do simple filtering, how you can do some aggregations and some transformations that will be 100% require some state. If you need to do aggregation, you probably put some of the aggregations inside your database. You need to maintain this database somehow. Kafka streams already includes this. So this is the part of the framework itself. Now, not going to talk about this very deeply. In the previous years, I did a bunch of talks about Kafka streams. You can look it up in YouTube, or so you can just like ping me in Twitter, and I will send you a few cool links. But most important thing, the Kafka streams actually ships with a framework that allows you to test your applications without even bringing any infrastructure. So this framework called Topology Test Driver. So, and what it does, it allows you to define something that will take your topology. Topology, it's the sequence of steps that your message will be going through in order to perform this like processing. If you have say a click event, we need to perform some aggregations. We need to get this some sort of ID based on maybe user ID or user browser ID or somehow. And after that, we get this as a group key. After that, we will need to perform this grouping operation to store this information for particular key servers. This is topology, also known as a DAG, which is called the direct acyclic graph that defines how the data flows through data flow. So topology is a very common term in a data processing system. So you define your topology and you write unit test. And this is not integration test, it is a unit test, because you don't need to, again, bring any Kafka, you don't need to bring any Zookeeper, any schema registry, nothing. You just need to define how your data would be piped into this topology, whatever data you want to pipe in to this topology, and after that, you can read this data and validate those results. So let's take a look how it's done. So let's take a look how it's done in a second project that's called Transform Streams, and it's the same logic of same application, but it is much more as a code. The logic looks exactly the same. Same code that I showed you previously. It takes the raw movie, performs split, after that extract this, and after that creates new movie. The way how it looks like from perspective of code, we're looking for something like topology. So build topology. This is where our magic happens. We define how we bring in data in, and after that we apply this map function in order to transform input data. Once we get this stream of events by string and raw movie, we get another stream of events by movie. Movie ID will be used as our ID, and the movie, it's a new object. And after that, we're writing data into another topic. As you can see here, this logic actually includes end producer and consumer. So that's why those are important things. And let me run this real quick so you'll see how fast this will be executed. So once I run this, it will compile, run, and program one more argument, path to configuration file. Really? Let me try to run this in the command line. Maybe in this case, it doesn't require any I'll do transform streams, or even transform streams. Testing streams. Gradle W transforming streams. Let's do test. So, and the result is almost instantaneous. So because it doesn't require to bring any, dependency like Kafka and so far and so on, it uses mock schema registry, which is also pretty cool. In this case, you wouldn't need to also have a schema registry as a container to run this. And the logic is absolutely the same. The logic is the same. So if I'll go here, say, because I didn't run the test. Okay, so I will be running this one. If I run the test, parsing, compiling, and this is the result. So it's just super fast. You can even just like have a watcher that will be converting this stuff. And so the key here is the topology test driver that runs this. We take the production topology, we're providing test properties, and after that, as a result, from test driver, we're creating topic where we're piping in data, and we have a topic where we're reading outputs. Once we get this actual output, we can compare those using whatever framework we're using. What we're using here, we're using also JUnit asserts here as our assertions mechanism. Okay, now there's not always unit tests are fixing, because you already seen these kind of pictures in the past where unit tests are passing, but integration test is something that fails. So things like this or things like this. So thankfully, there is a silver lining for this. Again, test containers also can be applicable here. And I did a live stream where I was breaking down this. You can find this recording on the YouTube. It's my YouTube channel. Go there, check this out. You can also press the pause right now. Just click this URL and watch it afterwards. I did have more time there, so I was able to go a little bit deeper. So anyway. And the last but not least is testing KSQLDB. So what is KSQLDB? So KSQLDB is a very fascinating tool that allows you to develop your applications without any, Java, Scala, or any language. It will use SQL-like language as your DSL to develop stream processing application. And also it supports things like stateful stream processing, stateless stream processing. All these things are built in KSQLDB, and also some of the cool things that built in is connectors that allows you to fetch the data from external services like databases and some of the whatever available as a connector. KSQLDB will be able to read from it. Another cool thing about KSQLDB is the KSQLDB ships with Test Runner. Test Runner is amazing small tool that allows you to take your topology that described in this case not in Java but in SQL and get input data, read output data, and compare this for you. So in this case, you can see this is a piece of documentation that you can find on the KSQLDB website. You can have an input file, output file, and SQL file that will include this. So let's take a look on this one. So in here, this is how this application looks like. Same application that we developed in our previous steps. The same application, but just like much more concise. So in this case, we don't need to write Java. So this is how we can do this. We have one stream of events that have a raw movie information, and after that we have another stream of events that we apply function on the fly. So we're extracting this here, extracting this title, and after that save it as a property inside it. How are we going to be testing this? As a result, we need to have an input. This is our input data that will represent topic information, and our object that we're pushing there. So we're pushing there this object with title and year, and after that we're getting output here. So how we can run this? So let me go there quickly. Where I am, cd testing transforming KSQLDB. So we can do. There's a couple things. This KSQLDB CLI, the KSQLDB test runner can be available as standalone application. But again, I like to bring this as a Docker service. So in this particular case, I'm just need to use this CLI. I need to start this KSQL CLI service. It's up and running. And next thing is that I will do this run test. So what this do is it run this with parameter input is our input data, parameter output is our output data, and our SQL file that will include our application. So when I run this, it will start, it will go and run this inside this container, and it says test passed. How we can make sure that this test is actually passing here? So let's see. It's going to be work in the cloud, say 96. So in this case, when I run this test again, I should be able to fail. So in this case, test failed, topic parse topic, message 2, expected 95, but it was 96 as a year. So in this case, it's not right, and it works. And let's see if we run this once again, and it also should work as promised. All right, so and into conclusion, what we have learned today. This is me banging my hand around when I was like facing some of the problems with my code in the past, but now I know how to test my apps, how to test the simple Kafka applications. For simple Kafka applications, you can use things like Topology test driver. You can use embedded Kafka, which is the framework that comes with Kafka. I don't personally like it or recommend this. I would rather prefer to use these test containers for testing scenarios. For Kafka streams, I would recommend to use a Topology test driver, which is a great tool that allows you to unit test your topologies and perform the things perform testing much faster. And for KSQLDB, obviously use KSQL test runner, so it's great. Test containers, again, it's a great tool. Highly recommend to check this out. And again, always be testing. All right, always be testing. If you want to learn more, about this, yeah, please go to this website called developer.confluent.io. Developer.confluent.io. Okay, remember? Also, you can go there and watch this awesome video that I did explaining why developer.confluent.io is my second favorite place on internet. And this is it for our journey. I hope this presentation was useful for many of you. My name is Viktor Gamov, and as always, have a nice day.